Welcome to the fourth video on Mechanics 2. In this video, we will discuss how a pendulum behaves inside a car which accelerates from 0 to a uniform acceleration A. In the third video, we discussed how a pendulum behaves inside an accelerating car which has a uniform acceleration A. What we observe is that the pendulum makes an angle theta with respect to the vertical. Now let us see how the pendulum behaves inside a car which accelerates from 0 to a uniform acceleration A. You all are familiar with the normal pendulum. If I displace the pendulum by some amount and I release it, the pendulum will oscillate about the mean position. And you all are familiar with the pendulum, and you can calculate the time period, which is equal to 2 pi into square root of its L by G. Let's see how a pendulum behaves inside an accelerating car. So when the car accelerates in this direction with an acceleration A, the pendulum will be staying like this, as if someone is pulling the pendulum in that direction. When the car moves in this direction, someone is pulling the pendulum in that direction, and that force is known as fictitious force, and we learned in the second video on Mechanics 2. Here there are two forces acting on the pendulum. One force arises due to gravity, which is acting like this, and one force arises due to fictitious force, which acts in this direction, and the resultant force is like this. If the car has no acceleration, the pendulum will stay like this. If the car is accelerating in this direction, then the pendulum will move by an angle, and the pendulum will stay like this. And from the second video on Mechanics 2, you know that this angle with respect to the vertical, this angle phi 0 is equal to tan inverse capital A by G, where capital A is the acceleration of the car in this direction and G is the acceleration due to gravity in this direction. If the car accelerates from rest, then initially the position will be like this, but if it accelerates to a value A, then the pendulum will make an angle phi 0, but due to kinetic energy, the pendulum will move by an angle phi 0 more, then it will oscillate about the mean position. If the angle between this and its equilibrium position, this is phi 0, the pendulum will continue phi 0 more angle in the same direction, then it will oscillate about that position. Now let us see that. So the pendulum oscillates about this mean position. If it has constant acceleration, the pendulum stay like this. If the car accelerates from 0 to an acceleration A, then the pendulum will oscillate like this. Now let's look into the free body diagram of this problem. When the car is not accelerating, the pendulum will be lying exactly down. That is, it will be aligned with respect to gravity. But when the car accelerates, the pendulum will get an extra force in this direction. When the car accelerates in that direction, the pendulum will get an extra force in this direction. That is a fictitious force, which is equal to minus m times capital letter A. Then pendulum will be pulled towards this side and gravity will be pulling. Then the pendulum will align in a line, which is the resultant of the fictitious force and the gravitational force. Now when the car is not accelerating, the pendulum will be at vertical. When the car accelerates, if the pendulum moves by an angle phi 0, due to its kinetic energy, the pendulum will move further by an angle phi 0. Then it will return back and it will continue the oscillation. From the second video on Mechanics 2, you know that this angle is tan inverse A by G. Phi 0 is tan inverse A by G. So phi will be equal to 2 times phi 0, which is equal to 2 times tan inverse A by G. Thanks a lot for watching this video. I am Dr. Pradeep, your physics teacher. If you have any doubt or comment, please comment below.